This dossier presentation is on Heparin Protocol. Before you attempt a math problem on Heparin Protocol, ask yourself two questions. First, is this an old or a new patient? An old patient is a patient who is already receiving heparin therapy. A new patient would be one that you're starting or initiating the heparin therapy on. Second question, is this an IV or a bolus? Remember, an IV is continuous infusion over time, and that a bolus is going to be a single dosage. This is an example of the Heparin Protocol, and when you look at Heparin Protocol, be sure you read everything on the protocol. In this example, there are lab orders, and I just want to draw your attention to number 3 and number 4. Number 3 talks about how often the PTT should be taken, and number 4 talks about the platelet count. And with the platelet count, it says that if the platelet count is less than 100,000, then you would stop the infusion. So that's something to pay attention to in your math problems that you receive on a test, is just watch for the platelet count if it's given. The main purpose of this dossier presentation is to talk about, though, the calculating of the heparin dosage. So when we're looking at the protocol, this protocol has the initial dosage, or when it says initial, it means starting. So this would be, we're starting heparin therapy on a new patient. So this top portion of the protocol is for a new patient. And heparin, of course, is based on weight. It's a weight-based protocol. So always change pounds to kilograms. But also, you can have two different types of problems. You can have a bolus question, or you can have an IV question. So if it's a bolus question, you're going to use what the protocol says to use, which is right here, which is the 80 units per kg. That is what the protocol says to use. And also to use the available for the bolus, which is the 5,000 units per 1 ml. So the bolus has a protocol, and the bolus has an available. When we take a look at number 3 with the infusion, the IV heparin continuous infusion, we see it has its own protocol, which is 18 units per kg per hour. So again, if we're initiating or starting a new patient on heparin protocol, we would use the 18 units per kg per hour. But the IV infusion also has its own available, which is the 25,000 units in 250 ml. So, as we discussed up here, this is for the bolus. And the bolus has its own protocol, the 80 units per kg, and the 5,000 units per 1 ml is its available. This down here is for the IV, and it has its own protocol of the 18 units per kg per hour, and the 25,000 units in 250 ml is its available. Let's take a look now at the bottom portion of the protocol, and that is for old patients, patients that are already on therapy, and we may be adjusting their therapy. And how we adjust the therapy is based on the PTT. So on the left is the PTT number, value, and on the right is the instructions on what to do if that patient has a PTT as listed on the left. So let's take a look at our first example. These are from the Math Practice Test number 2. This is given out by NIP, and this is question 2 in that packet. The physician orders the weight-based heparin protocol for a newly admitted patient in atrial fib. The patient weighs 120 kgs. The nurse will administer a heparin bolus of blank ml. Record your answer using 1 decimal place. So we ask ourselves the two questions. First of all, is this an old or a new patient? And when it says it's a newly admitted patient, that tells me it's a new patient. Then I ask myself, is this an IV or is this a bolus? And again, I look through the problem and I see that this is a bolus question. So it's a new and it's a bolus. Okay, so I know, now I go to my protocol, And according to my protocol, I'm using number 2 here because it is a bolus. So I'm going to use the 80 units per kg. So I go back to my problem, and it's 80 units per kg. So I look for the weight, and fortunately it's already in kgs, so 120 kgs. I'm going to multiply by the weight because it's a weight-based protocol. And I put that over 1, 120 kgs over 1. My kgs cross out, and when I multiply that through, I get 9,600 units. So that would be my bolus. So I go back and I look and see what the question was asking for, and it was asking for mLs. So I need to take this 9,600 units, and I need to go back to the protocol. And to change the units to mLs, I'm going to have to go right here to the available of the heparin bolus, and that's 5,000 units per 1 ml. So I go back to my problem, and 1 ml is 5,000 units. My units cross out, and I'm left with 1.92 mLs. I look to see what my rounding directions are, and they say to use 1 decimal place, so I would record my answer as 1.9. Okay, let's take a look at another example. This is from, again, the math practice, test number 2. This is question 9 in that packet. The boring patient has a heparin drip running at 10 mLs per hour and weighs 100 kgs. Lab APTT is 40. The bolus is to be given will be blank ml. Record your answer using 1 decimal place. So again, I ask myself the 2 questions. Is this an old or is this a new patient? Well, I know by looking at, they're saying the heparin drip is running at 10 mLs per hour. That tells me that it's an old patient. They're already on the therapy. So then I ask myself, is it an IV or is it a bolus? And again, in the problem, it tells me it's a bolus. So it's an old patient that receives a bolus. So if it's an old patient, I'm going to watch that PTT time right there, that PTT value. So I go to my protocol, and I'm using the bottom portion of the protocol, because remember the bottom portion of the protocol is for an old patient, and it was at 40. So that falls within this range, and my question was asking about a bolus. So I'm going to the protocol right here, which is about the bolus, and it says to administer 40 units per kg. So I'm not worried about the infusion portion. All I'm doing is answering the question about the bolus. So I go back to my problem, and according to the protocol, it's 40 units per kg, according to the protocol. I multiply by the weight, which the weight in this problem is 100 kg. So I multiply by 100 kg. My kgs cross out, and I end up with 4,000 units. Is that what the question was asking me for? It's asking me for mLs. So I take the 4,000 units, and remember, if I want to change to mLs, I have to go to the available for the bolus. So I'm down here with the bolus. The bolus has this available of 5,000 units per 1 ml. So whenever I'm dealing with bolus, that's my available. So I go back to my problem, and 1 ml with 5,000 units is my available for the bolus. So my units cross out, and 4,000 divided by 5,000 gives me 0.8 ml. So what I would record on my question, on my answer, is because it says to use 1 decimal place, that is 1 decimal place. And so I would leave the answer like that and record my answer as 0.8. Okay, so those are 2 questions on bolus. The first question, remember, was on a new patient, and this second question was on a old patient. So now let's move forward and let's look at a question involving an infusion. This is question number 7. Your favorite dog has just developed a DVT and requires a heparin drip. Since it is a Great Dane, it weighs 188 pounds. Labs converted from canine to human equivalents. APTT is 34. The initial infusion rate will be blank mLs per hour. Record your answer using 1 decimal place. So I go to my 2 questions. Is this an old or a new patient? And it says in the problem, the initial infusion. Initial means new, so it is a new patient. And then I ask myself, is this an IV or is this a bolus? Bolus. And it says here that it is an infusion, so I know it's going to be an IV. So I take a look at the protocol for starting an initial infusion, and I'm looking at the IV portion, which is right here, IV heparin continuous infusion, and according to the protocol, it's 18 units per kg per hour. So I go back to my problem, and it's 18 units per kg per hour. So I multiply by the weight, and the weight is 188 pounds, and when I take and I divide that by 2.2, I get 85.4545 kgs. And I don't round yet because I'm not finished with my problem. Remember, you only round once in a math problem. So when I multiply that through, the kgs will go away, and I'm left with 1,538.181, and that's units per hour. So I go back to my problem and I look to see what they're asking for, and they're asking for mLs per hour. So I'm going to take that 1538.181 units per hour, and I need to change it into mLs per hour. So remember, to do that, I have to go to the available. And with the infusion, the available is 25,000 units and 250 ml. So 250 ml goes on top, and the 25,000 units goes on the bottom. So my units cross out. I'm left with mLs per hour, and when I divide that through, or multiply that through, I get 15.38181, and that's in mLs per hour. So then I go back and I look at my rounding directions, and it says to use 1 decimal place. So my answer would be 15.4. Okay, let's take a look at another example. Let's move ahead. Let's take a look at this question. This is question 12. A plumber is on a heparin drip at 9 mLs per hour and wants to know what his new rate will be. His APTT is 72. He weighs 139 kg. Labs, platelets, 156,000. Hematocrit, 34. Creatinine, 1.4. Glucose, 134. The new infusion rate will be blank mLs per hour. Record your answer using 1 decimal place. So I ask myself the 2 questions. Is this old or new patient? It says he is on a heparin drip, and the rate is this. So it is a old patient. Then I ask myself, is this an IV or a bolus? I look and it says the new infusion rate, the adjusted rate, and that's going to be then an IV. So, since it's an old patient, I'm going to look at the PTT. The PTT is 72. When I have an old patient, I'm going to use the bottom part of the protocol. Remember, that is for the old patient, the patient already on therapy. And it was 72, so it's in this range. And according to it, the protocol, I'm going to reduce the infusion by 2 units per kg per hour. So I put a down arrow. It's going to be reduced by 2 units per kg per hour. So what I'm going to do is I'm reducing the rate he's on by 2 units per kg per hour. So I need to see what that is. So I multiply by his weight, and the weight is 139. The kgs go away, and my answer is 278, and that's units per hour. This is units per hour here, and this is milliliters per hour. So I can't subtract those, they aren't like units. So I have to change the 278 into mLs per hour. So I have 278 units per hour. And to do that, I'm going to go back to the protocol. But this time at the top of the protocol, I'm dealing with an infusion, so I'm at number 3, and the available is the 25,000 units in 250 mLs. So that's how I change the units per hour to mLs per hour. So my available was the 250 ml and 25,000 units. The units cross out. I multiply that through, and I get 2.78 ml per hour. So now I can go back to my infusion that's running, which is at the 9 mLs per hour. And I can subtract, because remember the protocol said to reduce, so I subtract the 2.78 mLs per hour from the 9 mLs per hour that he's on, and that gives me 6.22 mLs per hour. And I go back and I look at what my answer should be recorded in, and it should be recorded using 1 decimal place. So I would record the answer of 6.2.